Hello everyone, welcome to this video. In this video, we will see how do we implement the various orchestration types supported by Azure AI Agent Framework. So in the previous video, I clearly explained what are the orchestration type and how do we use it. If you need further information, you can refer to this particular blog where they clearly explain the various orchestration types. And if you need a code samples, you can always get it from Microsoft. So this is the link for that particular Git repo from where you can see the samples. So now let's go to the Visual Studio Code and see how do we implement this. So for this particular sample, what I want to do is that I want to write a kind of a blog. So I will be passing some input to the writer. Writer will be writing some draft, and that will be passed to the SEO. Then finally that will be passed to the editor agent to do the final review and publish the blog. So input, if you see, I will be passing artificial intelligence in 2026, and finally I will be having some draft version here. So now go and see the code sample here. So if you see here, I have three different agent: writer, SEO, editor. So now let's go and see what do we have here. These are all very simple class based executor. If you see here, the editor agent, it is inherited from the executor, and it has a single method called publish content. It takes the string as an input, and it finally yields the output. Pretty similar. If you just come over here, if you see the writer agent, this is again extended from the executor. It has a single method and it takes a string and returns the string. So you can very well replace the hard-coded values with LLM so that it will mimic the real-world execution. But that is not the whole point here. I'm just trying to show you what is this workflow it's all about. So now if I just come over here, I have a workflow builder. I'm setting this writer as a executor, and adding the edges from writer to SEO, SEO to editor. So now let me run the workflow. If you look into the workflow output, our input is passed to the writer, the writer's output passed to the SEO, SEO's output passed to the editor. Finally, we printed the result here. So this simulates the sequential workflow. Now let's move forward and let's talk about conditional workflow. So if you see here, we will be sending some input, and we will have some condition based on which we will execute one portion of the workflow. Say this is for a order processing. So if order it's greater than a certain value, we will apply some discount. If not, we do not apply any discount. And finally, we print the summary here. Let's go to the code and see how do we implement this. So if you see here, I have a parser order. So basically we will be sending the JSON as an input to the workflow. This parser order will convert the JSON into a object called order. Then in the age, we are adding apply discount with the condition when the order value is greater than 500. Then finally we will be sending to generate summary. There is going to be another route where we will not be applying any discount when the order total it's less than 500. Then finally we will be sending the summary here. So if you see here, we will be receiving the input here as a JSON. Parcel will convert to an object, and we will see if it is greater than 500, we will apply. Then finally to the summary. Same thing, if it is less than 500, it goes to no discount. Then finally we will be printing the summary. With that, let's go ahead and run the flow here. Let me clear the terminal. So this is going to be 31st program. If you look into the output, we are running two orders. First, we will have a large order. So this is the order total. And as you see here, 5% discount is applied, and this is going to be the final total. And we are also running a small order here. This is the total, and there is going to be no discount, and the final total, it will be the same. So this is how we can use the conditional flow. So we can also use the switch based condition here. Same around, what we want to do is that we will be applying a premium discount if the total is greater than 1000. If it is between 500 and 1000, the standard discount will be applied. Less than 500, there is no discount. So now let me go ahead and open the program here. If you see here, same implementation, we are using the parse order that will convert to a order object. If the total is greater than 1000, then we will apply a premium discount. Between 500 and 1000, we will apply a standard discount. If not, there is no discount here. If you see here, we are using the switch case here. So this is the first case, this is the second case, and this is going to be the default case. Everything else will be the same. So with that, let me go ahead and run the program. So if you see the output, we are processing three different orders. So if I just see here, there is a small order with no discount, and we also have some standard order wherein like 5% discount is applied, and we also have some premium order wherein like we have 10% discount. And this is how we can use the switch based workflows. And then we also have some concurrent flow. So let me expand this a bit. So if you see here, what we want to do is that we want to search the flight between Toronto and Bangalore, and there are some n number of providers. We don't want to go one after another, like when we say like go and search for the flight, we should be able to search across all the providers. Finally all the results will be sent to the aggregator, then finally we will print the best deal, right? So this is the real case implementation. So if you just go here, so here the flow, like we do a start with the search, then we create a fan out, in the sense like basically like from one node we will be sending the input to multiple nodes. Like from search we will be sending to Delta and United, and the like fan in the sense like from multiple nodes we will be sending the output to a single node, in the sense it is going to be the aggregator. So this is all about using fan in and fan out. From search we are fanning out, and then like from all other nodes Delta and United we are fanning in. So with that, like let me go and run the program here. Let me clear the console. So if you see the output, we are actually going to search first. From search we go to Delta, United. Both of these will be sending the results to the aggregator, and finally aggregator will be printing the best deal for us. So this is how we can use the concurrent. So basically the idea is that from one particular node we will be calling multiple nodes. From multiple nodes we will be combining the result into a single node. This is how we implement the concurrent flow. We can also use the constructor. So why do we use the constructor? We already discussed in our previous video. The reason is that the constructor or the class based implementation has multiple features. With the constructor we should be able to store and retrieve the information, right? So say like the same person is trying to get the result for the same date of same provider. You don't have to go and pull the information unnecessarily, rather like you can store that information in a database and then like pull that information. And that is how we can use the class based implementation, especially the constructor. So with that, let me go and run this program also. Let me clear the console. So if you see the output it is going to be the same, except that we are using the constructor based implementation. If we just come over here, if you look into the constructor right now, like it might not make a lot of sense, but now you know that you can very well use the constructor with the concurrent workflow. Now let's move forward. So far what we have done is that we have used executor as a node. So now in this program what I want to do is that I want to use the Azure agent as the node, right? So like what I want to do is that I want to create multiple agent in Azure, and then like I wanted to utilize all of these agent in my workflow. So let's see how do we do that. So if we just come over here, it will be the same exactly. We will be creating the agents here. So I create a writer, reviewer. Now I set this writer as a starter node, and the from writer we will be going to the reviewer. From reviewer we will be just printing the final result. So if you just see here, this is all a Azure AI agent, right? So this is not a typical executor. This is a Azure AI agent. So it has some instructions. So I create all of these. If you go to the Foundry, you will see all these agent. So now we create this agent in Azure Foundry, and we will be using this in our workflow. So now let's see how does it work. So this is going to make use of the LLM. So far like we have used all hard-coded values. Right now like we are moving away from the hard-coded values to make use of the actual LLM. With that, let me go and clear the console here. Now let me go and run the program. If you see the output, we are asking the LLM to create a slogan for the electric vehicle. So create a slogan for the new electric vehicle, right? And this is what given to us, and by the writer agent, that is reviewed by the reviewer agent. Finally we have the slogan for us. Now what I want to do is that I don't want to directly use the Azure AI agent, rather like I wanted to create the AI agent, but that will be used by the executor. That's what we are going to see here. So if you see here, I will be creating a executor, and this executor will be using the agent. Now let's go and see here. So if you come over here, there is an agent called a topic analyzer, and if you see here within the executor, we are creating or using the existing agent. Same case, I also have a summary agent. It also does the same thing. If you see here, it will try to identify the existing agent. If there is an existing agent, it will use it. Otherwise, it will create one and use it. Now let me go and run this program. Let me clear the console here. If you look into the output, it is going to create two agent here. So if you see here, first it create one for the topic analyzer. So this is the input we given, artificial intelligence, and it also create one more agent for the summary, and based on which it completes the workflow, right? So now what we have done is that we are using the executors, and the executors internally uses the Azure AI agent. Now we are making use of both the features to build our workflow. We can also modularize the overall workflow by using something called sub workflow or teams. So we will see how do we do that. Before I do that, let me clear this console here. So if you look into this, so this is my team or a logical group. So this is called a copywriting team. Underneath, like I have a writer and a reviewer. Both will be used if at all you refer copywriter team. So there is going to be input given that will be passed to the copywriting agent. This is going to be a sequential flow, this entire team. So the copywriter will receive this information, reviewer will review and pass the input to the next node. So consider this entire team as a kind of a node, though it has two agents within that. Now let's see how do we do that. So if you just come over here, we are creating a writer and a reviewer, and we are using a sequential builder, and participants will be both under like build, and we convert that as a team here by using something called as agent. By doing that way, the sequential flow will become a single logical group or a team. Now what we can do is that within our workflow, instead of referring to the individual agents or nodes, we can use this team agent as a starting agent, and this is going to be the next node. In this case, this is going to finally print the value, but in the similar manner, you can logically group your agents to work together. Now let me go and run this program. So if you see the output here, so we are asking the workflow to create a wireless toaster here. So this is the toaster. So basically, like the input will be passed to the team agent. Team agent consists of those two, and then finally the output will be sent to the final terminal, right? So far what we have discussed, you can consider it as a basic feature, though you can very well build the very complex workflows using these features, but still these are all very basic features. Now we will go and discuss about the advanced features. So let me clear this console. So first we will try to understand the difference between all of these. So if you see here, I have a comparison between handoff orchestration, group chat orchestration, and a magnetic builder orchestration. If you understand the difference between all of these, then it will become easier for you to use it. So first we will get started with the handoff orchestration. So think of this way, this is a support team. The triage person is the lead. So user support request will be given to the triage person. The triage person will be asking one of the support engineers to work on that. Think of this way, like the incoming request to return that item. Then the triage agent will be asking the triage specialist to perform the needed action. Then the person will respond back to the triage agent saying that the return is completed. Then if there is a need to process the refund, the triage agent will call the refund agent. The refund agent will respond back to the triage agent saying that the refund is processed or whatever is that. Now the triage agent will see if there are any pending action needs to be done on this user request. If so, it will perform. Otherwise, it will see the action is completed. You can think of like lead and the subordinate work together to solve a specific issue. Then we have this group chart. Again, like here we will have a lead. The lead will work with various agents. Say like there is a request to come up with some sort of brainstorming idea. So the lead will be asking, hey, who wants to discuss on this first? The security person will say, hey, I want to discuss first. Then he will provide the input to the lead. Then the lead will ask the cloud master, hey, like, do you have any input? If so, he will share that information. The lead will consider both the input, and if there are any additional discussion needed, then the lead will orchestrate. So basically, like, the lead here perform the orchestration, then the individual agents will perform the specific action, right? So this is more of a brainstorming ideas, or wherein like you want to discuss about some marketing strategy or something of that sort. You can consider this a group chart. Then magnetic, it's pretty similar to the group chart, except that the lead will come up with the plan. So even before it goes to the agent, various agents, subordinates, it will come up with its own plan, and it will get the approval from a human. Hey, like, this is what I'm planning to do it for this particular given task. Are you okay with that? If so, then it will execute the plan. First it will say, hey, like, I need to gather this information from the security, then I will ask these information from the cloud master and combine this result to provide the output, right? So that is what we will do with the magnetic builder. So slight difference between the group chart and the magnetic builder. Group chart, it's like more of a democratic way of doing it. Hey, who wants to go first? You have any additional input for me of something of that sort. Wherein the magnetic one, it's a plan based execution, more of a dictator, right? So the manager or the lead will decide what needs to be done. The subordinate will just execute the task. Now let's go and see in action. We will begin with the handoff flow here. So if you see here, the user request will be passed to the triage agent. The triage agent will understand what exactly the user is asking for. In this case, the user is asking for a return and a refund. So there are two action needs to be done. So the triage agent first will make a call to the return agent to process the return. Once the return agent respond back to the triage agent saying that it's done, then it will call the refund agent for the refund. Finally, it will print the result here. So let me go and run the program here. If you look into the output, so user is saying, hey, like, I need a help requesting for your assistant with the following issue. I need to return the order 101 because it is broken, and once the return is started, please issue the refund. Now the triage agent asked the return agent, and the return agent said, I have initiated the return, and the like a refund processing, it's a handed over. Now the refund process, it's saying that the refund it's initiated. Now triage agent, it's saying that the case it's closed. Now finally we have the summary, like what has happened. The overall summary it's here. So here exactly it says that user asked for a return and a refund. A return agent processed, refund agent processed, triage it's closed. So this is how we can use the handoff. Now let me go ahead and open the program here. So if you look into this particular program itself, it's a pretty simple. So we have a couple of agents created here. So if you just come over here, so we created some of these agents here using the Azure AI Agent Framework. We created the triage agent, refund agent, order agent, or return agent, or whatever the agent that you wanted to have. Now all of these agents are here. Now we wanted to build the workflow. So this time around we will be using handoff builder, and like we say, hey, these are all the participants and this is the name of this workflow. And the like start with the triage agent, and we see that each agent will get these many terms. So for instance, a triage agent can talk 3 times the overall execution. Refund order returns can talk 2 times in the overall execution. So depends on your need, you will be changing number of times the agents are allowed to speak. Now we need to have a termination condition, or when do we stop the workflow, right? So this is when the workflow gets completed. So first of all, we say that the number of messages in the overall workflow history, it should be more than 0, which means that at least you have to have one workflow history, conversation history. And then like in the message you need to have this particular keyword. It should say case is closed. because like now if you go to the triage, it is clearly saying that when all the tasks are done, you need to close the keys with this particular keyword. Now the workflow will get that information and it will see if the final history has this particular keyword in that message. If so, like it is indication that the workflow is completed. As simple as that. So now let's go ahead and talk about the group orchestration. So if you see here, so there is going to be a moderator or a tech lead who will work with the subordinates. So he will ask for input from both of these guys and like finalize the summary here. So in this case, let's assume that what we are trying to do here is that we wanted to migrate the payment gateway to Azure. We plan to use the public VM, SQL VM, to manage the cost, right? So now in this case, the tech lead will be asking here like this is the input that we have, and we wanted to do a brainstorm. The security agent will say something, and the tech lead will be asking the cloud master, basically the architect, and finally he will prepare the overall summary here. So now let me go ahead and run this program. Now if you see the output, this is what we are asking. So this is the proposal, and if you just scroll up here, first the security pro is speaking. He is saying something. Then the cloud master is speaking. Then what do we have? Then again like the security pro is speaking. Then finally we have the final outcome here. So the overall proposal is this, and this is the final outcome here, cloud master outcome. And finally like the security pros are speaking. Then the tech lead says that let's proceed with the migration timeline and begin with the implementation. Thank you for whatever is that. So now as you see here, whenever you wanted to have a discussion between the agents, then you can very well use this group chat orchestration. Now if you look into the code, it will be very simple. So if you see here, so we are saying like we will be using the group chat orchestration, and this is the lead, and these are all the participants, and this is the termination condition. So this is how we build the group chat orchestration. Now let's also talk about the magnetic orchestration. It will be the same sample, but we will be using the magnetic orchestration. So here we will have a lead, and we will have a participants. The overall workflow count, overall number of times the workflow can run between the agents, it's a 6. So what will happen is that when I input it's given, the lead will come up with a plan and request for a manual approval. Once it is approved, the lead will call the individual agents and finalize the output. So if you just come over here, so this is how we build. So here instead of a group chat, we will be using the magnetic builder. So if you see here, we are using group chat builder. Here we are using the magnetic builder, participants, and manager, and the maximum count is 6. So it's a global limit, not necessarily for the individual agent, but the overall communication between the agents, that includes the lead and any other agent that participates in this workflow. Then finally we will come out of the iteration and print the result. Let me go and clear this console. Let me run the program. So if you look into the output, it did go through a lot of iteration. Finally, this is the outcome that we have. It says that do not use the blob storage, rather use the SQL to store this information. So far in this video, we have covered all the orchestration types using which you can build a basic workflow to a very complex workflow. Now in the upcoming video, we will be discussing about workflow events, based on which you can get the human approval. Say you want to do something, before you actually perform any action, you need to get the human approval. That is mandatory, right? So we will see in the next video how do we do that. Thank you for watching.